The first thing you need for SpeedPORT is the Kiwi Wi-Fi device, which I have already plugged into the OBD socket on the vehicle. You turn on the Wi-Fi by sliding the power switch located on the side. Now that the Kiwi Wi-Fi device is turned on and plugged into the OBD socket, we must set up the mobile device to communicate with the Kiwi Wi-Fi. This can be done by going into the Settings applet. You'll notice that under Wi-Fi, it already says SpeedPORT. Your device may not, so I'll show you how to set that up. Under Choose Network, you will see that either SpeedPORT or PLX devices, depending on where you purchased your Kiwi Wi-Fi. In this case, I'll choose SpeedPORT on the right to go into the configuration screen. Set the IP address type to static and type in the following for IP address: 192.168.0.11, and for the subnet mask, use 255.255.255.0. Those are the only values you need to enter. You can now exit out of the Wi-Fi screen and go back to the main menu. The SpeedPORT application is very easy to use. After the initial splash screen, you will notice the main menu, or home screen as we like to call it. From here you can select Profiles, Scan Codes, and Data Dash. You'll notice that all the icons are initially inactive and there is a blinking red LED in the top right corner of the screen. It will keep blinking red until it connects to the vehicle. Once it's connected, the LED will turn solid green and all the icons will become active. Note, on some vehicles, this can take up to 10 seconds. The Profiles module connects you to the AutoSpeed software that has been loaded on your vehicle's ECU. Once connected, it will identify the program, in which this case is a Stage 1 stock hardware tune with the following profiles: stock performance, 91 octane, 93 octane, 104 octane, valet mode, and anti-theft mode. You'll notice that the 93 octane is the active program as indicated by the green LED on the bottom right of the icon. On the bottom of the screen, in the status area, it also indicates that the current profile is 93 octane and that the current mode is unprotected. This means the vehicle is not in valet or anti-theft mode. I will demonstrate how anti-theft mode works. Simply choose the theft icon. For safety purposes, a message box asks if you are sure that you want to activate this mode. Selecting yes enables the anti-theft mode, and the vehicle immediately shuts off and will not start even with the key as witnessed here. A quick look into the status area shows us that the vehicle is in a protected mode and requires the security code to re-enable the performance profiles. In this case, I'll select the 93 icon and enter the PIN code screen. For an example, we'll enter an incorrect PIN code of 1234 to demonstrate the security of the app. We'll confirm our entry by clicking yes, and you'll notice that the program rejects this PIN and returns us to the PIN entry screen for another attempt. Now I'll enter the correct code for this vehicle. I'll confirm my entry, and you'll notice that this time the active program changes to 93 octane and is in an unprotected mode once again. The valet mode is a reduced performance profile in which we may only have 50% throttle, a lower speed limiter, or lower rev limiter, and this varies from car to car. This is pretty much it for the Profiles module. I'll hit the back button to return to the home screen. The Scan Codes module is where users can retrieve, view, and reset diagnostic fault codes that the ECU may have stored while the vehicle was last used. As you'll notice here on my dashboard, the check engine light is on. I took the liberty to unplug the intake temperature sensor so that a fault code would be stored by the ECU. So what we'll do is, we'll go into the Scan Codes and we'll actually scan the vehicle's ECU for stored and pending fault codes. Right away, it comes up with one fault found. The description indicates that the P code of 0113 and the description is intake air temperature sensor 1 circuit high, indicating an unplugged or faulty circuit. If there are multiple faults present, you would use the left and right arrows to view the codes. In a typical situation, you would write down the fault numbers and use the factory repair manual to diagnose and rectify the problems. Once the problems have been resolved, you can hit the clear button. Hitting yes, the faults are now cleared. You can see on my dash there's no longer a check engine light, and in the application it says no faults found. We'll hit the back button and return to the main menu. The last module is the Data Dash module. This is where users can select, monitor, and record various live engine parameters. The 4 buttons that you see in the corners are live hot buttons. These allow the user to select different engine parameters. First, I'll select timing advance. Then, I'll select RPM. I'll select one more parameter. Let's view calculated engine load. These are all live engine parameters. So as the vehicle's engine is running and I rev the engine, you can see the values all respond in real time. If you have a turbocharged car and your vehicle's ECU is loaded with AutoSpeed software, you will then also have the center boost gauge functioning in real time as you are driving down the road. The record button records the selected live engine parameters. Once it is recording, the stop button becomes active. When I hit stop, it'll tell me that I just saved data to a CSV file. Then the user can later retrieve that data using a third-party app to review the data for purposes of analysis or charting. That's pretty much it for the Data Dash module. Next up, we'll take a drive to illustrate the boost gauge in action real time.